Hello everyone, I'm Akash from Data Science branch. We are we are here presenting the new assignment. Our topic is a decision tree. I'm explaining about the introduction of this topic. Uh, import numpy has np import and ds as pd import c brown and sns import from multiple palette as PAT from scalar model selection import train test split from scalar preprocessing import from mini maximum scalar lib encoder from scalar neighbor import from classifier from scalar tree import decision tree classifier from scalar navy bias import from guess nb from scalar matrix import from accuracy score precision score small score font score classifications uh, load dataset file path dfpd.read SV, csv command clean column names df dot columns is equal to df columns star spread further continued by Karthik.
Hello, I am Karthik from IS department. My topic is check if customer ID exists before dropping customer ID column, but only if exists. If customer ID is DF columns, returns the list of all columns named in the data frame. A DF drop customer ID axis 1 in place true. In place true modifies the data frame directly without needing reassignment. Handle missing value. DF drop NA in place true. Convert gender to numerical values. DF gender is equal to labor encoder fit transfer DF gender. Purpose remove any row in the data frame that contains missing NaN value. Next, in place true applies the change directly to the DF. Next, define target variables spending category. DF spending category is equal to DD cut if DF sending score 1 to 100 B beans 0 40 60 100 labels low medium and high. Purpose converting categorical value in the gender column like male female into numerical forms like 1 and 0. Label encoder is the class from sklearn pre processing fit transfer learns the encoding and applies it in one step. Ensure at least 2 samples per category. Class count. DF spending category value count. Spending score into categorical range. Valid class count greater than 1 index. Keep class with greater than 1 sample. DF is equal to DF spending category is in valid classes. Normalize data. Scalar minimize scalar DF age comma annual income K dollar. Spending score 1 to 100. Scalar fit transfer DF age annual income spending score 1 to 100. PD cut splitting the score into 3 bins. Result new column spending category. Purpose counting how many samples fall into each spending category. Return something like high, medium, low. Purpose keeps only category that have more than one sample. Prevents issue during training model. Classification requires greater than or equal to 2 samples per class. Purpose spending category is one of the valid category with more than one sample. Is in valid class. Returns the true for rows with acceptable category labels.
Hello everyone, I am Tipeswamy B. I'm from ISC department. We are working on the customer segmentation using the K nearest KNN classification algorithm. Our goal is to predict the spending category of customers based on their age, income and spending score. We use scalar is equal to minimum and maximum and scalar. We apply minimum and maximum scaling to normalize the features age, annual income and spending score. This scales the data to a 0, 1 range, which is essential for distance based algorithms like KNN. And we use data splitting Python. X is equal to df drop spending category, comma axis is equal to 1, y is equal to df spending category. We separate the features and the target, then we split the data set, train test split and satisfy is equal to 1. Using satisfy is equal to y ensures each class in the spending category is proportionally represented in the both training and testing sets. Model training, knn is equal to k neighbors classifier, n neighbors is equal to 5, knn dot fit x train y train. We train a knn model with 5 neighbors. This model predicts category based on the majority class among the 5 nearest data sets. Prediction, knn dot predict is equal to knn predict x set. We use a trained model to predict the spending category of the test set. This pipeline is a simple but powerful for categorical predictions. When the data is when data is well processed, normalization and satisfaction improve both fairness and accuracy in classification. Next will be continued by Gagandeep BS.
I am Gagandeep BS from Data Science Department. So this is our project decision tree. As trained decision tree model, dt is equal to decision tree classifier, random state is equal to 42, dt dot fit x train comma y train, dt dot spread is equal to dt dot predict x test. As train new says model, nb is equal to Gaussian nb dot fit x train comma y train, nb pred is equal to nb dot predict x text. As evaluate the performance. Definition, evaluate model y test y pred model name, print fn performance of the model name, print classification report y test comma y pred. Evaluate the all models. Evaluate model y test knn pred kn. Evaluate model y test comma dt pred comma decision tree. Evaluate model y test nb pred naive bias. This is our the project of the output. Thank you.